this is Kiara and I'm doing practice problem number 17 from the book. So here's the question. So as you can see, part A asks us to draw the Lewis dot structure, so that's what I'm going to do. First, you start off with the elements that you have. So I have carbon, and then I have chlorine and fluorine. I know that carbon likes to make 4 bonds, so I can make 4 bonds with a carbon. I know that fluorine and chlorine both have 7 valence electrons because of where they're located in the periodic table. So you can draw their valence electrons. And so one of the valence electrons would be shared with carbon, and then one of the carbon electrons would be shared with whatever it is, whether it be the chlorine or the fluorine, and that's how it makes the bond. So that's how all of them complete the octet rule. And yeah, that's the Lewis dot structure. Next, I'm going to predict the shape of the molecule and state the bond angles. So if you remember what the bond structure looked like, it had all equal amounts of lone pairs, or the equal amounts of electrons on each element. And so this means that none of the bonds would actually repel each other, and so they'll all be equally distant from each other. So it would look kind of like this. So this means that it's going out, and this means that it's going backwards. So then they're all like equidistant from each other. They would be 109.5 degrees away from each other, and it would be a tetrahedral. The next question is asking to state, giving reasons, whether it's a polar or nonpolar molecule. And so I say it's a nonpolar molecule because the bonds have equal polarity and are arranged symmetrically. If you can remember what the shape of the molecule looked like, it was all equal distance away from each other and at a 109.5 degree angle. So what this means is, like, you know, they're kind of all canceling each other out, all of the charges, because they're all in like opposite sides from each other. So for our next part D, here is the Lewis structures of the ozone O3 molecule. And so what it's meant is by resonance is the fact that like either one of these molecules could be the correct way to write the molecule. However, no one's really sure which one it is. It could be either. So that's what it means by resonance, is that it has 2 different molecular structures or Lewis dot structures. The difference between the 2 bonds here, as you can see easily, is that the O2 bonds are double bonds and the O3 has a double bond and 1 single bond. Again, it's a resonance structure, so we don't really know where the single bond is. However, there is a single bond, which means that there would need less energy to hit that single bond in order to break that off. So that's why it'd be more easily broken down than the O2. In the stratosphere, the UV rays hit there because it's like a part of the atmosphere. And so when the UV rays hit it, that's when the bonds are broken. Thank you for listening to my video.